An update on the project build. It's been a while since I've made the last video, and I don't remember how much I went into detail of what is what on this project, so I figured we'll just kind of walk around it, and I'll explain to you what I've done so far and what parts are being used and how things are coming together. So yeah, check it out. So a drilled and dropped Model A style front axle on a front leaf spring, T-bucket leaf spring, and split wishbone, just aftermarket radius arms. 32 forward headlights, 32 lowboy radiator. The engine, the crown jewel. The late 90s M62 B44. It does have a M60 B40 cams and timing chains and idler gear and the double row chains and everything. The ITBs are an aftermarket kit meant for the Toyota 1UZ platform. The bolt spacing and ports have been adapted on those aluminum chunks that you're seeing under the manifolds on top of the heads there. The fuel rails are also aftermarket for 1UZ. Made my own throttle bell crank. I have some work to do on that guy. The headers are aftermarket turbo kit headers meant for the Ford modular V8 platform. They are turned around backwards, and I'm using bolt adapters that I've made off of header flanges for the M60 heads or M62 heads. There's the oil filter adapter kit. Gets rid of the canister oil filter and lines that was originally on these engines. Exhaust is a Pipes M80 and a 4-inch turnout that's been tigged directly to the muffler body. And then the muffler's been tigged to the header collector. Just one unit, clean and simple. I know you've been eyeing what's going on with this ignition and distributor. What the hell is going on here? Underneath the nameplates on the valve covers are Volkswagen Audi R8 style ignition coils, self-igniting coil per cylinder, and the ignition wires are a guitar speaker cable that have two 16-gauge wires running through them. One is for plus 12 volts to each coil. The other is the plus 5 volt trigger to each coil. Then the coils ground on the cylinder heads by their mounting there. The plus 12 volts and the 5 volt trigger for each coil gets run into the distributor. It is wired for waste spark. So one cylinder from each bank, two cylinders get paired together on the trigger side in the distributor cap there, and then run out the bottom of the distributor body. For some reason, each one of these throttles has a vacuum port that is above the throttle blade, ported or timed vacuum port. So it wouldn't receive any cylinder manifold vacuum with the throttle closed. Only the frontmost and the rearmost cylinders on this kit have a vacuum port that is under the throttle blade and receives what would be manifold vacuum, cylinder vacuum. So I've got 4 of the vacuum lines going to what would have been a multi-carburetor fuel distribution block, but now it's a vacuum block, and then it's going to a pressure transducer. So that's a negative 15 to plus 15 psi pressure transducer that's acting as a 2-bar map sensor. And I do that because I like having atmosphere be 100 kPa no matter the elevation. That way elevation changes are happening on the baro table of the fuel injection with a separate baro sensor and not on the VE table. But that's just one of my personal weirdness things. Yes, the fuel tank is hovering in midair in the middle of the car. It's going to be located underneath the cowl of the T-bucket body. That fuel filter is going to be sticking up out of the middle. Yes, it does have that little mechanical fuel level gauge that is also going to be sticking out of the top of the body. That was one of those weird ideas that I wanted to try. A far more talented fabricator could probably make a tank and then pressure test a tank that would fit the space more gracefully. But this works. It fits, I think it's like 8 gallons. So it's not a whole lot. Fuel fill-ups are going to be pretty frequent. But yeah, keep an eye on the fuel level as you're getting in and out of the car because you won't be able to see it while you're driving down the road. The transmission is the native BMW GetRag 420G. I believe it's the E38, E39 variant. In fact, I know it is. I know it's the E38, E39 variant because it has a different input spline size than the E34 version. And it has a slightly smaller clutch disc. I think it's 240 mil versus 260 mil. That one is the E34 GetRag 420G 6-speed variant with the larger clutch, 260. And this one's going to have 240. And I don't think it's really going to make any bit of difference. I did do a lightweight aluminum flywheel with that steel face. I think it came in at like 12, maybe 14 pounds when I weighed it. So it's a pretty lightweight flywheel. The idle is going to be pretty high because it's not going to have the rotational mass to idle down real low. Same story with this one. This one has the lightweight aluminum single mass flywheel, and idle is like higher than 700. I think I keep it around 750. Pretty tight squeeze with the 3 pedals. I'm going to have to rethink my accelerator pedal. You see, I did do it on a bell crank, and then it's going to pull the cable, and then the cable is going to go up to the other bell crank. All the bell cranks. I need to add some stiffening or a metal plate or something for this foot to sit on. I broke this foot off on the other transmission, so I want to make sure I don't do that. That just while driving, just while applying torque, it actually snapped the aluminum down here, so I want to prevent that from happening on this project, this build. The steering gearbox is Tri-5 GM. I did that because it had a really long snout on it that I could stick out the side of the cowl, stick out of the side of the body for cowl steering. It also had this built-in really long steering shaft. It was way longer than what it currently is. I've cut it down to put the steering wheel where I wanted. The steering gear has been reversed. In fact, I have a little bit more work to do to kind of tighten things up and make that all happy. But I've modified my own mounting here. So we've got that mounting, we've got that mounting, we've got that mounting, and then there's one more on the other side we can't see from here. So four places for the steering gear to mount to my, I'm calling it a bulkhead. I don't have any other term for what this DOM tubing middle support section that I've built for this project. I'm calling it a bulkhead. I'm way happy with the way that this differential turned out. 70s Jaguar. I found some way oversized 12-inch? 14-inch? 12-inch. Brake rotors, of course, slotted and drilled for the aesthetic. Real thick and vented. And that is off a modern Stellantis product. Like their small SUV, and I think some of the more Euro-oriented cars, like the Dart maybe, I don't remember, but modern Stellantis brake rotors. Yes, I did have to drill my own bolt pattern for the Jaguar axles, but the bore spacing was actually correct. I did use spacers behind the rotors. Can we see them back here? Kind of. Those spacers are also from Jaguar. When Jaguar got away from the integral brakes and rotors and moved them outboard, they put that spacer in between the differential and the axle in place of where the brake rotor used to be. So I do have a spacer to kind of put those things out and move them where I want them to be. Big old Willwood calipers. Those have presented a problem for mounting. But they're on there. Did have to make my own caliper mount plates that are bolted to the stub axle housings on the inside there. I'm not sure where I found this finned differential cover for the Dana 44, but I really do like it. I think it's a pretty classy looking piece. I do wish it was fully polished, but that's okay. It looks good. I had to take some chunks out of it for banjo bolt clearance on these calipers as things slide and move around. Yes, I did use a leaf spring that is mounted to a plate that is underneath the Jaguar rear end. I started with a Willys Jeep leaf spring, and then I added T-bucket leaf packs on top of the Willys leaf spring for support and kind of lift things up. The Willys spring was just way too weak. I've been playing with that today, adding leaves, taking leaves out, changing the short leaves and long leaves and everything. And right now I've got it a bit high, but this is offering the most support right now. And yes, I have to address that bolt hole. But yeah, that rear leaf spring on the Jaguar rear end was an idea that I had. I just wanted to kind of get out into reality. And it's working so far. You see, I do have the front tie bar. And then I'm going to be using these big heavy-duty Heims to kind of help transfer some of the loads to the frame. I think we'll just have to see what happens long term. I think I can get away with this idea simply because this car is just going to be so lightweight. You know, if there was any real load to it, I'd have to come up with another way to get the leaf spring loads transferred to the frame directly. Okay, keep moving around here. Speedy EFI fuel injection controller. That is a WTM Tronics UA4C inside a project box with mountable end caps and wiring harness offered by Speedy EFI. And I've been real happy with that EFI controller. It is meant for the Speeduino platform. I have since converted them over to STM32H7s, running a fork of Russ EFI called Epic EFI. I've been real happy with the Epic EFI firmware. Of course, I've been running it on this guy here too. But yeah, that's kind of my go-to on these kinds of projects. I decided to put the ignition key and the turn signal switches and the headlights kind of in the middle here, so when you're sitting in the seat, everything is going to be just kind of underneath you, behind you. That was another idea I wanted to run with. Got wiring absolutely everywhere. I haven't made the radius arms for the Jaguar rear end quite yet. I want to get the ride height dialed in with a stiff enough spring to support the loads before I make the radius arms, but I do have the mounts and the provisions built into the frame. And those are in line with the pivot points of the control arms for the Jaguar rear end. Or real close to it. Now that we're on this side with the ignition coil, The bank 1 plus 12 volts and the bank 2 plus 12 volts are isolated. So I used the same guitar speaker cable that has the 16 gauge wire running through it. So bank 1 and bank 2 plus 12 volts are run through the speaker wire, and then they get split and they get run to each terminal. So I think that's bank 1, that's bank 2. I don't remember. And then each of them get their own separate power supply run over here. These headers were a little funky to work with because clearly they were never made for this application. I do enjoy using as many off-the-shelf or prefabbed parts that I can modify to work on my projects as I can. That way there's not a whole bunch of one-off stuff that will have to get recreated when things break, because they do. I gave myself some tunes on this one, using just some universal Bluetooth speaker meant for a motorcycle. External, way large fuel pump. It says USA Performance on it. I think it's Speedmaster, which is not USA. But I am using dash 8 through the whole system. And just got to make a little shorty hose to come out of the bottom of the tank to the inlet of the fuel filter. The body up here, Speedway is calling this a 25T, and I don't know what the difference is between the 23T and the 25T. That one's a 23 body. This one's a 25. This one has a door that I started cutting things away where I probably shouldn't have because I haven't figured out my hinges and latches yet. But yeah, real basic like golf cart bench seat that actually fits pretty well. You know, I was thinking I can cover it with a blanket or do a seat cover on it or something. The floor is 60s and 70s Volkswagen Beetle floor pan that I've cut up. And the trans tunnel, I think, is meant for like a GM A body that may or may not work for what I need it to do. We've got a added on extra tunnel dash fiberglass piece that kind of brings the dash engages away because the tank is directly behind the original dash. There'd be no way to actually fit any gauges in it if I didn't do the tunnel dash. Plus, I think it looks kind of cool. 60s Mustang gauge bezel that I think looks really neat there. I haven't figured out the gauges I'm going to run for it yet. And the holes for the filler in the fuel gauge I was telling you about. And my 2 upper halves 32 grill shell with 1/2 flipped upside down and welded together. And that's going to be the front grill for it. And that's going to be the grill insert for it once I cut it up and bend it into shape. Which is, I think, the same MO, same exact thing I did for this guy over here. So that's 2 32 grill shells, 1 flipped upside down, and then that's that same exact truck billet grill insert for that guy. So yeah. Sweet. Did I talk about my shifter? No, not yet. Yeah, I like these real long shift handles on them. It does make shifting the gears, especially where I put the pivot point on this one, like rowing a boat. That's a lot of swing to get from, that would be 3rd to 4th, 1st, 2nd, 3rd to 4th, 5th, 6th, and reverse is way over here. There we go, reverse. It actually contacts the steering wheel. To get my H pattern, I had to do something funky with a little Heim joint and then make my own adapter on top of the BMW piece. But that gets the H. Yep. Sweet. I am currently redoing the fuel lines up top here. I originally did have, we had a inlet over on this side here from the fuel pump, and then go through 4 cylinders, and then do a crossover hose, and then 4 more cylinders to the fuel pressure regulator, and then out and back to the tank, which is what this provision was going to be. I decided to clean up the front end a bit by getting rid of that crossover hose that was at the front of the fuel rails, and I'm going to deadhead the rails. So I'll put some 10AN plugs in here, and then we will have the fuel come in on this side. It'll deadhead through one rail, it'll cross over back here, deadhead through the other rail, and then regulator back to the tank. Instead of a fuse box, on this build I opted to use a PDM to send power to everything. So there's a Row AmpLink programmable PDM. It is solid state, so I believe it's MOSFET. And you use an app on your phone and it connects to Bluetooth to it, and you can program what turns on or what turns off each channel independently. So I do have things like the electric fuel pump, the cooling fan, and do I have headlights in there? No, I don't think I have the headlights wired to it. But the problem when you try and control an electric motor like a fuel pump or a cooling fan from a MOSFET is when the motor turns off, it sends a flyback voltage back to the MOSFET. So to handle that, I'm going to be using these heavy-duty diodes that I'm going to put terminals on and heat shrink over and put them directly on the terminals of the fuel pump and the cooling fan to snag any kind of flyback voltage before it can find its way back to the PDM when the fan and the fuel pump get turned off. And there it is with the seat in place. To get the body mounted is a whole ordeal, including removing the steering gearbox, putting the body on carefully, and then feeding the steering gearbox back through. But I can at least show you with the seat mounted. God, that really is cheap, but that's okay. It fits and it works. I'm content with doing a little bench seat like this. I really am just making a little street cruiser for fun. I figured, not that they would ever get used, but there is an outfit that's selling vintage style, like 1960s and 70s GM style seatbelts. So I will add a couple of seatbelts. Yeah. We're getting there, man. Thanks for checking out my project and my build thus far. I hope you enjoy what you're seeing. I am always open to receiving feedback. If you've seen my build, as I've completely spammed them all over the internet on every single automotive forum, that really is kind of what I'm hoping for, is for people's feedback, to tell me yay or nay, or hey, I did that, it didn't work. Hey, I did that, it did work. But yeah, totally. Thanks. I'll see ya. I wanted to chime in here and clarify something real quick. This is my bench EFI test setup here. That's the same exact EFI controller that's sitting in the car inside that box. You can see it's buzzing away on the bench at about 2,500 RPM. This build with the independent throttles is going to be running in alpha N logic. So that means that the VE table, which I will show you here, and same for the ignition table, but the VE table is going to be run off of engine RPM versus throttle position instead of manifold vacuum. simply because independent throttles don't have manifold vacuum or very good manifold vacuum. So you run them off of throttle position sensor, which I have one set up here on the bench, and that is going to be the load axis, is the throttle position sensor. The reason why this build has that map sensor, or the pressure transducer sensor that I'm using as a map sensor, in the background of the fuel calc to get to the injector pulse width here, it multiplies the VE value by the current map sensor. It's called map multiply, and a lot of EFI systems do this. So the primary load source for this vehicle, for this build, is going to be the throttle position sensor. But the map sensor is working in the background and multiplying the VE value by the current map that it's reading to give the injector pulse width. So I did want to clarify that. It's not going to be running on speed density. The other build, the supercharged build, runs off of speed density, which is that load is done by the map sensor instead of throttle position sensor. But the independent throttles is going to be alpha N. Sweet, thanks.